In this video we will explain how to create the first project with HELIOS3D. There are several ways to insert survey data or already prepared surfaces to the drawing. Here in this video, we will use the classic insert commands to load the drawing as an external block. So I use classic inserts and then I choose the prepared surface. At any time we import data, we make sure that the data appears at the original location, so there should be no rotation, scaling or changes to the insert point, or geoposition, and we want to import the data directly, not load them as an external block, so explode should be enabled and then we hit OK. After that, we can use the mouse wheel to zoom to the data and to the original location, and in this case we have a surface with a 2D polyline, which is prepared already as fence line for the plant. The first thing we need to do with the surface is to check that there are no serious issues with the surface, like holes or points without any elevation or a wrong elevation. This can be checked with the object viewer by selecting the surface and then loading it into the object viewer. By changing the perspective, we can see if any holes or wrong data are included. If that's not the case, we can continue. Then we need to set the coordinate system. That information can only be retrieved from the original data source. There's no way to guess that information. One way to do that would be the map status bar. So when the map started bar is shown, you can just go to the bottom line and choose the coordinate system from the library. Here you can answer the EPSG code or type the name of the coordinate system like ETRS89.U. And then choose the correct zone. The advantage of this is that we can afterwards show the aerial map, which should confirm that there is no wrong positioning. There should be no wrong scaling or rotation or when the map shows in a wrong location. This is a hint that the data doesn't fit together. So from the survey point of view, you can't use that data without checking why the information doesn't fit. For Helios, we don't need the aerial map all the time, so I close it. The first thing we need to do would be moving to the project settings and setting the latitude and longitude for the sun calculation. The latitude and longitude can't be set directly, but in a special edit dialog, where we can set the two values, directly type them, copy them, or we have several other alternative information. We can set use to calculate the data like UTM or different import formats. In this video we use a KML file from where we read the latitude and longitude and confirm the data with OK. At the end, we need the two values in here and we can continue with the time zone. Without the time zone, the calculation of shadows will not be accurate. The reference angle for any layout can now be set by either a date and time, which we use to calculate the sun azimuth and altitude, or you can set individual data by overwriting the two values without choosing a date and time. In that case, you just use the two checkboxes. In this video, we use our default suggestion, December 21, 12 p.m. At this point, the project data is set, and we can go to the placement function. If the placement list doesn't show the surface, even though the surface should be there, you should refresh the list. In that case, the surface entry should appear. Otherwise, please check the format of the surface. When the surface is ready, we can add boundaries, an outer boundary as area, and after that, the fields as closed polylines. So you can start either adding existing data and registering the orange-colored polyline with Add as Area, and you can confirm the registration with right-click or Enter. In the naming dialog, you can then set the name, like Alpha Boundary, and you can continue creating the fields either by drawing individual fields inside the boundary or by offsetting the line to the inside with the AutoCAD command. In this example, we use a 5 meters distance and register the offset polyline as our first field boundary, and registered that boundary as field. With the first field in the list, we can select the field node, and on the array subpage we can assign the first array we want to use for the placement. Here we can just add an existing array from the database, and decide if the smaller version of this array should be placed in addition. For example, to fill gaps at the end of a row, if the big array doesn't fit in. Then we go to the field properties and start our first layout by setting the placement options. We can start with a row distance, a minimum row distance like 2 meters. We set the placement directions for the racks, the module inclination, like 20 degrees, and the distance between neighboring arrays. The placement can then be started with the Auto Placement command. Then we have our first table layout.